Hi everyone, so we continue callable bonds, but we have more complicated product. The redemption value is varying. Okay, example 3. Our 15-year bond with 4% annual coupons is callable at t is equal to 6, 7, 8, 9, 10 with redemption value of 116. Okay, and t is equal to 11 to 14 with redemption value of 106. So we have different conditions for these two time periods and determine the present price to yield 2% effective. So of course the bond may not be called, so may be redeemed at 15. Okay, think about the time diagram. So time diagram that we have the 0 to 15. So we have 0 to 15. And 1 to 5, the bond cannot be redeemed. 6 to 10, the bond can be redeemed at 116, and 11 to 14 redeemed at 106. So the cash flow is $4 each. And finally, you have 4 plus 100. Yeah, and yield rate is 2%. So how many possibilities for issuer? We have actually the 10 possibilities, the callable at 6, 7, 8, 9, 10, 11, 12, 13, 14, and not redeemed, 15. So we actually don't have to compare all 10 cases. So I will explain this. So at first, focus on the first 5 options. Call at 6, 7, 8, 9, 10. And actually, between these 5 cases, the 6 is optimal. So for the issuer, t is equal to 6 is better than t is equal to 7, 8, 9, 10. Because the coupon rate 4% is lower than yield rate of 2%. So coupon rate is higher than yield rate. So that means basically the issuer wants to stop paying the coupon. So t is equal to 6 is better than t is equal to 7, 8, 9, 10. So we can eliminate the possibility of t is called at 7, 8, 9, 10. And how about 11 to 14? It's the same thing. So still the coupon is $4. So the coupon rate is higher than this yield rate of 2%. So that means issuer wants to stop paying coupon as early as possible. So 11 is better than 14. So t is equal to 11 is better than t is equal to 12, 13, 14. The same reason, coupon rate is higher than yield rate. So we can eliminate the possibility of 12, 13, 14. And 15, we are not really sure. So basically we have to compare t is equal to 6 and 11 and 15. So we only have to think about the 3 cases. And redemption values are different. T is equal to 6. You can stop paying coupon earliest, but the redemption value is 116. So this is the worst for the issuer. So it's not clear which is better, t is equal to 6 or 11 or 15. So still we have to compare these 3. So now we can calculate the value for each scenario. So if called at 6, what's the present value? So present value here is, so we have $4 6 times and actually redeemed at 6. So we have this timeline. So 4 times $4 plus $100 at time 6. So P is equal to 4 times A right angle 6 at 2%. And plus 116, sorry, not 100, 116, because redeemed value is 116 at time 6. So 116 times 1.02 to the power negative 6. So this is present value of the redemption value. So this becomes 125.41. Okay, so now that we calculate the case that the bond is called at t is equal to 11. Okay, t is equal to 11, then P is equal to 4 times A right angle 11 at 2%, and the redemption value is 106. So if redeemed at 11, 106. So 106 times 1.02 to the power negative 11. So this becomes 124.40. And if it's not redeemed, not called by t is equal to 15 until 15, then P is equal to 4 times A right angle 15 at 2% plus 100 times 1.02 to the power negative 15. So this becomes 125.70. So we compare these three values. Then t is equal to 11 is lowest. So this one is lowest. So the P is equal to 124.40. So this is the answer. Okay, so this is an example for the varying the redemption value. Okay, see you then.